Hi, this is David Loshin, President of Knowledge Integrity, with an answer to today's Ask the Expert question. Is master data management different for operational systems than it is for analytics? That's an excellent question which indicates some thought regarding the business requirements associated with the master data asset. Clearly, it's not reasonable to believe that a transition to using a master data environment can be all or nothing, especially in an environment with complex application dependencies and different expectations for the creation and use of master data. Rather, the transition, as is suggested by the question, will focus on the usage situations or scenarios as directed by the business application clients. Note that the services and architectures suitable to one scenario may not necessarily be the best suited to another scenario. Adapting MDM techniques to qualify data that is used for analytical purposes within a data warehouse or other business intelligence framework may inspire different needs than an MDM system designed to completely replace all transaction operations within the enterprise. If we think about the proposed business benefits of MDM, such as comprehensive customer knowledge, consistent and accurate reporting, improved risk management, improved decision making, regulatory compliance, quicker results, and improved productivity, we start to see that the use of master data spans both the analytical and the operational context, and therefore this helps in considering the usage scenarios to which MDM is going to be applied. Master data objects will flow into the environment through different work streams. However, business applications treat their use of what will become master data in ways that are particular to the business processes they support, and migrating to MDM should not impact the way those applications work. Therefore, while we anticipate that our operational process may directly manipulate master data as those applications are linked into the master framework, there will always be a need for direct processes for creating, acquiring, importing, and maintaining master data. Reviewing the ways that data is brought into the master environment and then how it's going to be used downstream provides some input into the selection of an underlying architecture and the service model. So let's look at a few usage scenarios, and then at a global level we'll consider some of the implications. First usage scenario is reference data. In this scenario, the focus is in importing data into a master data environment and the ways that that data is enhanced and modified in support of dependent downstream applications. The expectation is that as data is incorporated into the master environment, it's then available for publication to client applications, which in turn may provide feeds back into the master repository, all for the purposes of reading or writing, but very rarely writing reference data. For example, an example would be a catalog merchant that resells product lines from numerous product suppliers. That merchant's catalog is actually composed of entries that are imported from catalogs presented by each of that company's suppliers. And the objective in this reference information scenario is to create a master catalog that can be presented to the end stream customers by combining the product information from the supplier catalogs. And in this scenario, data enters a master repository from multiple streams, some automated, some manual, with a concentration on ensuring the quality of the data on entry so that it can be a high level of confidence in the use of the data by the end customers at the actual applications that are relying on that catalog. Another scenario is the analytical scenario, and analytical applications can interact with master data in two different ways: as the dimensional data supporting data warehousing business intelligence, and then for embedded analytics for inline decision support. One of the consistent challenges of data warehousing is a combination of the need to cleanse data supplied to the warehouse to establish trustworthiness for downstream reporting and analysis, and to manage the issues resulting from a desire to maintain consistency with the upstream systems. Analytic applications are more likely to use rather than create master data, but these applications also must be able to contribute information to that master repository because it can be derived as a result of analytic models. For example, customer data can be managed within a master model, but customer profiling application may analyze customer transaction data to classify customers into threat profile categories or into categorization for different kinds of customer relationship management techniques. These profile categories in turn can be captured as master data objects themselves for use by other analytic applications such as fraud protection or compliance with Bank Secrecy Act or compliance with other kinds of privacy protection regulations in an embedded or an inline manner. So in other words, integrating the results of the analytics within a master data environment supplements the analytic applications with some real-time characteristics. A third scenario is operational usage, and as opposed to the other scenarios, some organizations may want to eventually supplement all of their application data systems with the use of data coming from that master environment. This essentially dictates that operational systems have to execute their transactions against that master data environment instead of their own subsidiary data systems. And as these transactional systems and the business applications migrate to relying on a master environment as the authoritative data resource, they're going to consume or produce master data as a byproduct of their own processing streams. And so they begin to replace their own data silos with reference to the master data asset. So for example, an organization may want to consolidate all of its views of all of its customer transactions across multiple lines of business and multiple products lines to enable real-time upsell and cross-sell recommendations across the different product lines and lines of business. And this desire is going to translate into a need for two different aspects of master data management: managing the results of customer analytics as master profile data, and then real-time monitoring of all customer transactions. So that includes purchases and returns and rebates and any type of inbound call center activities and interactions, attrition, etc. Each customer transaction is going to trigger some event that requires an action within a specified time period, and all those results have to be logged back to the master repository in case there need to be adjustments made to the different customer profiles and those models in real time. So let's think about some of the impacts associated with all these different usage scenarios. Each of these sample scenarios has implications in terms of selection of an underlying master data management architecture, largely having to do with the degree to which the dependent applications are tightly coupled, the need with of how close they need to be to the master data, the degree of consistency that the applications need between themselves with respect to the master data, and synchronizing across the enterprise in both the analytical and the operational applications as well. So for example, with an MDM system that supports reference data, the applications that are the sources of the master data might operate at their own pace, creating records at any time, but at some point down the road will be recognized as master data. And if the reference MDM environment is intended to provide a common system of record that's not intricately integrated into real-time operation, the actual data that comprises that master record could be managed by different application systems and materialized on demand using the MDM environment solely as an index for searching, seeking out records, identification of the locations where those records exist, and applying the survivorship rules on demand when a specific record or set of records is requested. In that case, you can rationalize the identifying attributes on a periodic basis, so it doesn't need to be done in real time. But there really is no need for real-time synchronization, and an architecture to support that may require a master model that manages enough identifying information to provide searching and indexing and identification and registration, as long as the remainder of the master data attributes can be composed from redirection or pointers from that master index. In the fully operational usage scenario, all the interactions and transactions are applied to the master version, and the consistency requirements have to be enforced at a relatively strict level. So as opposed to that reference scenario, that situation is much less tolerant of replication of master data across different data silos, and suggests that there should or might be a single master repository that's only accessed directly by a service layer that manages the synchronization and the serialization of transactions from the multiple applications. So trying to bump up the serialization and transaction semantics from the system level to the service level for master data management. Then that analytic scenario, it presents a less stringent need for control over access. Much of the data that populates master records is going to be derived from source application data systems, but only the data necessary for analysis might be required in that master repository. So since master record creation is going to be less frequent, there are going to be less stringent requirements for synchronization, for consistency in real time. And in that environment, there may be some combination of a master index that's augmented with the extra attributes that support the real-time analytics or the embedded monitoring and embedded reporting. The upshot is that the implementation team should defer the selection of an underlying architecture and implementation scheme until there's been some evaluation of those different usage scenarios and their business application dependencies. Once that's been done, the different operational requirements will lead the designers to make the most appropriate decisions regarding the underlying architecture. That was a great question. Thanks a lot for listening, and hope to see you at the next Ask the Expert question. Looking forward to that. Bye.